real scared. Who's scared you?
DSP.
Yeah, that's true.
Can we get started? So I think I want to do a survey first because next week we are going to do get into the lab and do some soldering with the board, and there will be some testing as well. So we need probably 1 or 2 hour blocks. So in that case, I'm thinking about shifting my office hours to Thursdays instead of Monday, Wednesday, Friday. Because I know you guys are probably busy with classes in the mornings. Okay, right? How many of you are really available during 9 to 11? You are available? You? Anyone else? So it's a bad time frame actually. So what I can do is 1 hour Monday, Wednesday, Friday, and then maybe 3 hours on Thursdays. What time on Thursday works for everyone? It's not just for individual ones. Everyone probably need to come on Thursday because a lot of times you need to know how to, at least for the first 4 or 5 weeks, I think, before you really are super good at oscilloscopes and function generators and the measurements. I'm not trying to leave anyone behind, so all of you have to be an expert after this class. This is the only chance you are learning PCB design and building systems, okay? So Thursdays working with me will be super important for your career, I can say.
I'm free anytime.
Anytime Thursday? Any time or any time you are not available, just let me know now.
Any time outside of 12 to 1.
Okay.
I have something from 1 to 2. Anytime before 3 o'clock.
Wait a second. Did you say? 1 to 2?
1 to 2.
Not available.
No.
Okay.
There we go.
You?
Anytime before 2 to 5 o'clock.
Before say again, before 2 or after 5?
So before 3 o'clock.
Before 3 o'clock. You won't be available before 3 o'clock.
No, I'll be available before 3.
Okay, then after 3, right?
Yeah.
I'm free all day Thursday.
You?
After 5.
After 5? I'm in bed after 5, so it's okay.
After 11.
Okay.
Anytime after 11. It's fine.
Okay, cool. So before 11 a.m., right?
After 2:30 p.m. I'm not available.
After 2:30. Okay. Simple math. work on this after class. I'll email you guys after this, okay? I'll email you when will be a good time for us. It's AND logic, right? It's AND. Is it AND logic?
I think you're going to get all zeros.
We'll see, okay? I think we were at this one. So maybe someone didn't really get it, but now let's write it down so make it super clear for you guys. There's a quiz today at the end of the class, 10 minutes for, maybe 15 minutes, I'll give you 15 minutes to work on the number systems. It's very similar to the problems on the homework assignment. I'm not going to create anything new for you guys, for the homeworks, for the exams. So everything you have seen already, then I will put on the quizzes, okay? So for this one, it's basically using your brain as the CPU of the Arduino to run the for loops. So just tell me the results, okay? So see, unsigned integer 8-bit type I, there's space in the middle. So the I is the first one, and you can declare 2 variables at the same time and separate them with a comma. So comma count. And so I didn't assign any initial value, so I doesn't have a very clear initial value, but usually by default it's 0. Okay. For count, I put a 0 here. I'm just trying to make it clear it's counting from 0. Okay. And here, this one just overwrite whatever the original value of I is. So for the for loop, I initially was 200. When I was larger than 100, and then I plus 1. So in last lecture, I told you guys this I plus 1 assigned back to I happens after the execution of the everything in the curly bracket. So in that case, it's checking this condition, giving the initial value first, and then check the condition. All right, it shows you the order, right? So do this first, and run this, and eventually add a 1 to I. That's how that works. So you think about that. It's the instruction pointer in the memory system, the instruction memory. It's taking out every single instruction each time from top to bottom. So it's taking out this one first. I find out it need to check the condition. It checks, and then get into the loop, right? Execute this line. So originally I was 200, right? And get into the loop, count becomes 1. All right. After that, your I becomes 201. Oh, sorry, 201 afterwards. So until this becomes 255, so it's actually counting from 0 to, so think about that. Whenever I got a 200 here, starting from 0, and then right after that, count becomes 1, okay? And I becomes 201, becomes 201. That's a 1 period of execution. And so in that case, whenever this reaches 255, what is count by the moment during that or after that execution? Because 0 to 55, you got 56, right? So count added 56 to itself. So it becomes 56, right? Because the first time you got a 1, right? After the 56th time, you got a 56, so count will be 56. And then right after that, I added 1 to it, so I becomes 0, right? Because a bit, all of you know a bit is a byte, right? So a bit, it carries out, so clear out all these 1s, become 0, and then you gotta carry out at the 11th bit. No, 9th bit. So I becomes 0 and count becomes 56. What about the next one? So keep in mind, I'm putting the code here. These are not pseudocode. I modified them so they can run in Arduino systems. So when you are turning in your code, it doesn't matter it's being typed in there. You can type it. You verify on the Arduino I gave it to you last time. Verify it, and then you can either find the PDF. Is there a PDF of this guy? I forgot. You send a PDF. If not, just email me. I can upload to Canvas. So you can copy and paste to this paper electronically, and then upload it if you are typing, right? Because every time you type in Arduino, you verify it. You probably don't want to directly just handwrite on the paper again and scan, right? So you can directly verify it, copy and paste, and put on the paper and scan and upload. The reason for that is it's a super practical class. We're not really writing pseudocode on the paper. You have to run, it has to work. If I see your code on the paper is not really, for Arduino, it's not working, I won't give you the credit. Just keep in mind. Sometimes, depending on if I'm having a good day or not, if not, I probably will just give you a 0. Because it's not working, right? If it's not working, you're not getting credits. Very simple. So this one, look at it. For Arduino, it's different from C++ because it's using a serial communication. Why it's called serial? Because it's comparing to parallel. So in old days, we don't have the serial communication protocol. We do parallel because you can see very old machines, computer machines, has a lot of parallel pins on the back. So a very huge port with all the parallel pins. Imagine that it's just assigning digital signals to the port once a time, and all the data is available at the port. It's communicating parallel in a parallel way. What's the benefit and what's the disadvantage of that?
Yeah.
Pros and cons.
Like throughput with parallel?
Higher or low?
Higher.
Yes. What's the cons? What are the cons? So why the throughput is higher? Because you are not, pumping out single digit one by one, right? So all the data will be available. It's like 12-bit data that are being sent to the ports, are being available on the put on the ports at the same time. So you got the data ready, during the same time frame, during the same clock cycle. So the cons are just taking a lot of space. So the ports pins are very expensive on chips. Imagine that our computer system are 64-bit computer systems. So it's basically 64 pins, 64 digital lines every time for each data frame. In that case, if you are using parallel, and our Arduino, think about the Arduino Uno board, right? So that chip has only 28 pins. You won't be able to handle that. I mean, even you have 100 pins like the Arduino we are using this semester, 100 pins, and you're taking 64 pins just for one type of communication. That's crazy. So we're not doing parallel anymore. I think this is we start doing serial communication maybe 60 something years ago. So it's not a new technology. There are a lot of serial communication protocols. So serial means it's just one line, sometimes two lines, but most of the time it's one line. For the ones we are using serial, it's called UART. Remember the name? Universal Asynchronous Receiver Transmitter. Got it. So this one becomes very popular because it's very simple, even though it's low speed. So there are ports. Anyone knows what are the ports available for UART? What are these ports?
Something like
TXI.
TXRX, yeah. 2 pins for data communication. Everyone needs to know this for the interviews. Okay, for the interviews for any companies doing embedded systems, they can ask you that. So TXRX, one is for sending, one is for receiving. So you need another. If this is transmitter, this is receiver. And so the TX need to be shorted to RX, and RX need to be shorted to TX. All right. So this one could be a sensor. Could be a desktop computer, could be a laptop computer, and this could be an MCU, your microcontroller unit. So they can build communication. Doesn't matter which is which, okay? Because as long as they have TX and RX, the communication can happen. So for this case, we call it serial. Doesn't mean UART. It doesn't mean serial is UART. However, UART is serial. You see the logic? Because serial has UART, SPI, even USB. What is USB? What does that mean?
Universal Serial Bus.
Yeah. I2C.
Oh.
Okay, so these are all the popular serial communication protocols we have.
Yeah, and isn't there something called like DART as well?
What's that?
Isn't there something
DART?
called DART?
How to spell that?
Like DART? Is something called DART or no?
Oh, probably a new protocol. I don't know.
Okay.
Yeah. There's also for motor vehicles, it's called CAN. It's a CAN bus.
Okay.
Right, so all these are serial communications. Okay. So that's why I'm saying UART is serial, but serial is not UART. Now, however, in Arduino, which is use serial, but you know that it's UART. It's not SPI. It's not I2C. It's not USB. It's just UART. Okay. So serial dot begin. So you are actually initializing that serial port. Everything's running behind the scene. It's setting up a bunch of registers. So you know registers are, this is the very beginning of the semester, so I think I should be very clear on that. These are just very small memory banks in the CPU or outside of the CPU. So these are 8-bit registers. So a lot of times we just write 0x or 0x something to make configurations to the registers. So these registers are doing a lot of things, including configurations, setting values, or setting operating mode. It's like something you put in, like a push button on the remote controller. You push some button, you put your TV in a certain mode, right? But there's nothing that fancy for your microcontroller. The Arduino doesn't have a push button on a remote. It's all programmable. You have to program a lot of registers to set up all these modes. Okay, so you want this one working for ADC mode, and ADC has all different modes as well. For UART, you want to set up the transmission rate, the baud rate, or the other things, a lot of other things you need to set up. So you are using registers to set up. So this line doesn't show you all the setups, but it's running behind the scene. You have to know that. The IDE does that for you, which is good. And there are a lot of other tools are also setting up everything behind the scene, but it's very interesting because they want to help you to set up everything behind the scene, but they are still making that very complicated to work with. Like the PIC microcontroller I used at mine in the fall last year, and it's configuring the tools that took maybe 50% of your time in the class, which doesn't make sense. So I used whatever I taught over there, I put all the sensors and everything on our board or the Sky board, but I switched everything to Arduino from PIC. So PIC is a brand of microcontroller. It's been super popular before Arduino became popular, and the company is called Microchip. Microchip acquired Atmel. I should use uppercase. Atmel is a company makes all these Arduino chips, but something years ago, maybe 5-6 years ago, Microchip, which is a way bigger company, acquired Atmel. So now all the Arduino chips were actually you consider they are from Microchip. So it's a very big company. I think there's a branch in Colorado School of Mines. If you know how to do digital design, there's a chance to get a job over there. Is there a difference? Yes, because it's a bigger platform. You can see a lot of people have a lot of eye-opening, lectures and seminars and projects as well. But still, undergraduates, it's usually like 95K as a starting salary. Microchips. It's similar to all the different sectors we have, even in Durango, 95K, 85K, something like that. So PIC was the older product from Microchip. So it's very buggy. If you have to use it in industry when you get a job, your boss told you to use it, good luck with it. Even though it's very popular, but there are so many other platforms are way better than PICs. So students at mine suffer because they have to use PIC. Anyway, so I think Arduino's is a lot easier, and we don't have to do all this unnecessary debugging for the tools. And even for the connectors, you look at our Arduino, the very big USB connection, you plug in, it shows up. For the PIC, you use the micro USB, you plug in, you wiggle it, plug back in, takes 10 minutes just to get a connection. So have to crack. So that's the first line of the setup for the serial. So on the top here, I believe you don't have question for that. Just declaring the two variables, unsigned integer, right? And then you have a void function set up. So you have to follow this format in Arduinos. It's going to be different from other microcontroller platforms. So you have to have a void set up first, and then followed by a void loop function. Can you have sub functions? Yes, you can definitely define your own functions and call it from either setup or loop. However, setup and loop have to be in there in your code. Do they have to be void? I don't know actually. I'm sorry, but I've been using void all the time. Maybe you have to use void. You can try it and let me know. Okay. So make sure that in your Arduino code, before you program anything into it, first time, the first line you want to type in there is void setup, okay, and parentheses, and curly bracket, which is your code in here, and then followed by void loop. So all the functions and lines in setup only run once. It's only run once, and this will run back and forth all the time, depending on your code, but mostly yes, it's going to run back and forth. So especially whenever you part it up, it get into set up all the variables and get into the setup function and run this for once. It makes sense. You only need to set up the serial baud rate for once, right? And then you print. This is what I was trying to print. I just printed one value and see if that works. And then it jumps into the loop function and going top to bottom and then going back and forth all the time. As long as the power is on, it's going to keep doing this. Or you have sometimes it's technically called interrupt. If you have interrupt routine, it's going to interrupt the loop and run the interrupt routine and come back to the loop. We'll learn interrupt a lot. It's going to be a major part of this class for this semester. Very important. So this one, going back and forth, this one just one time. Okay? So having that in your mind, what is this? Function. Oh, I have a function here. Okay. So what is in the loop function? Nothing. See the curly bracket? I don't put anything there, which is fine. Okay? It's fine. I mean, even though it's so what's gonna happen is whenever it runs this one, it calls a function. See, I have a custom the function here. It's called my function, parentheses, and it's gonna call this function here. Right, it's gonna run this guy. Okay, and then jump into loop, and loop has nothing in there, just stuck in loop, which is fine since I'm done with all the tasks. So I'm sorry I was saying it's gonna run back and forth over here. It's actually wrong because this is not the loop function. The loop function is over here. I didn't see that. Too small. I was thinking the whole thing is a loop function. It's not. Did you see that?
And then, so with,
Yeah.
with that, since I is 200 and
Uh-huh.
you're running the loop until I does not equal 100, will it loop all the way back around to like the maximum the number can hold for the 8-bit? Or, yeah, because can't an 8-bit only hold two?
Yeah, so
Is it-
so when it's not equal, when it's not 100, so it is not 100, right? So, but when it becomes 0, it comes back, because there's a 1 is going to somewhere,
Yeah.
but all the 8 bits are starting from 0, counting from 0 again, counting up to 100, right? So
Yeah.
that's how that works.
Yeah.
So when it equals to 100, it's gonna stop. So before it reaches 0, 255, let's say,
Yeah.
so count is giving you 56,
Mhm.
right?
Yeah.
And then starting from 0 to 99.
Yeah, that'd be another 100, right?
Yeah. Let's see how many, what's the numbers? Starting from 200, doing this, you got a 1. So whenever this reaches 255, you got a 56. And then you got a 1 to 99. So
That'd be 100.
so it's 56 plus 99, right?
Why not 0? Isn't it
Wait.
0 to 99?
Yeah.
Yeah, 99 because it's right before 100, right? And then after that, this one add a 1. So I actually, after that, after 99, I becomes 100. And then comes out, it doesn't satisfy, so it's going to stop adding 1 more here.
Yeah.
Okay? So you are basically having 156, 155.
Yeah.
Let me check the solution here if I'm wrong. I put 156.
Yeah, because
So I'm asking counter.
Yeah, it's the 0, right? Because like you run at 0 and then you do it.
Oh yeah, yeah. So it's 0 to 99. Yeah, 0 is another count. So it's 100. Thank you. Okay, go through this one more time if you are not getting that. Okay, next. Read Arduino code to create an unsigned 2x2 array. Okay, so this is something we need to know how to create an array. I think. Do you have your Arduino board with you?
Yeah.
Everyone? Anyone doesn't have it? You don't have it? You can grab it now. Yeah, let's do it. Just make sure everyone can communicate with the board. Do you have it? I believe the desktop has Arduino IDE. If not, there should be a portable one on the website you can download and doesn't require you to install it. when you start a new page or new code, it's called a sketch. So they call your code snippet a sketch. That's okay. Just understand what's going on there. So you click File and New, right? It's gonna generate a new platform for you. You don't really need all these things. But you can see that by default, it already put a setup and loop function there for you. So look at number 6, problem number 6. The goal is to create unsigned 8-bit number array, 2 by 2. So basically 4 numbers in that array, 2D structure. And print out the number at row 0, column 1. It's really simple. So when you have to print something out, you need a serial communication. But we have variables, so at the very beginning, I think we should, this is optional, but usually it's good practice. I don't want to keep giving numbers into the arrays when I declare it. So what I'm trying to do, I'm trying to use a variable here. I forget the name of it, but I'm just defining n as 2. It's a 2 by 2 array, so it's going to be n by n array. The benefit of doing that is every time you want to change the whatever being stored in n, you can just change it on the top, because there might be a lot of 2s, 2 by 2s or whatever in the following code. So you just keep using n's instead of using numbers, right? So let's define that first. And because this is a unsigned 8-bit array, so we name it array 1, because array itself is a keyword, so I don't use that. I just put array 1. So here we use n here. And so I have to use curly bracket for all the numbers. So first curly bracket, I think there's a better way to do that. Let's just do this. I change the new line, and I do 0 and 1 for the first row, and you need a comma to separate them. And I put a 10 and 11 for that. And I want to align that curly bracket, but it's not allowing me to do so. You know, I usually, so that's why in the future you need to learn a Vim, right? The Vim is way nicer, but this is okay. Just a little bit mouse operation. Anyway, so creating an array like this will make it very clear, right? And I think this one was generated by the curly bracket I typed at the first time, so I want to delete it. I don't need the 2. It's just basically 1 here, 1 here. Okay? So that's how you declare your variables. And now I want to print it out. And I just want to print it out once. So definitely not in the loop. And you'll see if you put in the loop, it's going to keep printing. There will be a lot of printing in the serial monitor, but I just want to do it once. In this case, for setup, I really don't need to do anything else. I will just set up the baud rate, the transmission rate. A lot of times they call it baud rate, B-A-U-D-E, baud rate. Serial dot begin. It's uppercase S and lowercase b. You can see it changes color, which means it's a keyword, which means it's right. You can choose 9600, but you can choose other speed as well. But I just use the regular 9600 by default, so I don't have to change it in the serial monitor. So it's 96 bits per second. And then I do a serial print. I'm printing a line. So if you do a print, it's not changing the line. If you do a print the line, after it printed out, it's going to directly change the new line to print another one. So it's asking you to print out which one? Row 0, column 1. So just put a 0 here and 1 here. And close it with a semicolon. And that's it. Just keep it blank in the loop function. Nothing. Okay? There's nothing else you need to do. So it's probably asking to save it. I'll just put on desktop. As it's asking you to name it, rename it. If you want, you can do it, but I don't have to. Right. And a very good thing to do in the future, because you probably are making snapshots of the code. When I'm grading it, I'm telling you like line 5 has an error, line 20 has an error. So in that case, you want to show a line number here. All right. So how to show a line number? I think it's in one of the settings. I Googled it 2 weeks ago, but I forgot. Aging, bad memory. So Google it, you can find out. It's easy. Have a line number in your IDE, okay? You don't have to do it now. I'm just saying in the future, making snapshot, you want to include the line number there, so it's easier for me to refer to which line during the feedback. So now you're ready to program it. So click Tools and go to the board. I already pick up the Mega 2560 board and find out that board here. Make sure you find it, the right board. And then go to port and pick up the COM4. Now that tells you this is Arduino Mega 2560 board. You select that one. So, however, sometimes it's not showing up in the serial port. Like all the computers already have a lot of port. So in that case, it's confusing. There are multiple ways to find out the right port, which you directly connect it to the Arduino. Just press the window key. If you're a Mac, I don't know where to find it, but definitely you can Google it later. But press the window key, type device manager, as it shows the device manager, and then you scroll down. You can find the COM ports, COM ports, and you can see the Mega board over there. It says COM4, all right? So that's another way to find it. So now it's ready to program. So press the arrow key here. It's programming. Just compiling the code first, and then you download it to the board. What's going on? Wait.
You're missing a semicolon at the end of your double bracket. So like if you go up to like your last one.
Oh,
Yeah.
this one?
Line 5, you need a semicolon after it.
Here?
Yeah.
Oh yeah, that's right. I thought this was a function. Yeah, it's a variable. You're right. Thanks. Run it. And then go to Tools, open the monitor. And it's gonna print 1 for once, right? Okay. Does it work for you? Okay. Number 7, problem number 7. Any questions for this one by far? So the Arduino board has a serial UART port on the chip, and that chip is connected to the little serial to USB converter to the USB port, and it goes to the USB to your computer. So you must have question. Hey, it's USB. It's a USB port. It's not UART port, right? So there's the chip. If you look at the board, there's a little black square next to that USB port. That is a USB to UART converter. Okay, so Arduino board directly communicates with the laptops through the USB and print out something over there. And you can select everything here, and you press Control and slash. Control and forward slash. Is that forward, backward? Forward. It's leaning forward. So the forward slash, which is with a question mark on the keyboard. So you can start typing the next one. So what's the next one? For following code, if I use this, a specifier, numbers. Oh, this could be a little bit tricky for people that didn't take C++. It's not difficult at all. Let's look at it. This guy. You have heard about specifiers in C++, but probably if you didn't take C++, you don't know that. So the specifier is specifying the certain format of the output. So you see that you use a percentage sign and followed by that specifier, and it's actually telling you you are printing out a unsigned byte, unsigned number. If you have a percentage sign with X, you are printing out a hex format. Even though it's the same number, okay, it's the same number, like 10, for example. I'm printing out 10. So this one is going to print out 10. It's an unsigned decimal, I'm sorry, it's an unsigned decimal, and this is the unsigned hex. So if I'm doing this, it's printing out 10. Because it's unsigned, it's treating that binary number as unsigned, right? And it's printing out 10. This guy will print out what? Uppercase, lowercase. Actually, it doesn't matter. Sometimes it's printing out uppercase, sometimes printing out lowercase. I think it's probably by default it's printing out lowercase. It's probably lowercase. Yeah. Is it printing out 0x as well in front of it? Do you think the C compiler is printing out 0x for you if it's a hex number by default? No. You have to put a 0x as a text in front of it in order to show that this is a hex format. Otherwise, it's just an A. So you have to tell people this is 0x, it's not A. Okay? Otherwise, it's like a letter. All right? Now look at the questions here. I don't know if this is already, oh, actually it does. You can see the setup is a loop. I think we should type it in there. Should we? It's taking a lot of time. Probably not. Let's don't do that. So character, so characters in here, it's a 4, you have 4 spaces in this character, but you only have 3 letters. So why do I need the 4 spaces? So it's a character variable. It's actually a string, right? It's called a string. So for people who didn't take C++, I'm sorry, but it's just a very simple concept. So it's just a series of characters. Is a string. Okay, it's a string. That's a data type. It's a data type in C or C++. So if you do a char, it's a character type string, because this string has all the characters in there, and the name of the string is called alphabet, right? And then you have 4 spaces over there because all the strings has to be ended with a noun. So here you couldn't see it. It's not visualized. You cannot visualize it. It's just nothing. It's like an ending mark for a string. So whenever you declare a string, even though you only need 3 spaces in there, but you need to give 4 spaces when you declare it, because you need an ending. By default, whenever you declare it, the compiler will directly give you a space at the end. It's an ending mark, which is a noun. It's a character as well, but it's a noun. Okay, just nothing. You couldn't even see it. It's just nothing. So in the computer system, there will be a space over there. It's a byte being given over there. It's a byte. It's 8 bits. Just to let you know. Okay, that's how that works. You know, we need an ending mark. So whenever we are scanning through the string, we know that if we see a null, we know that it's done. It's the end of the string. Okay. So here, why do we do that? I'm gonna come back to this later. And now, see, I'm doing setup function. That's a tradition. We have to do this in Arduinos. And then I'm doing this. Why? I'm thinking, hey, I'm printing out a string. I can directly just print it. Okay, and without specifying anything, which is fine. But now you have to specify what kind of format you want to print it out. So in that case, it doesn't like your Windows or Mac computers. It can directly do that for you, just one line of printing. But here, it's just 8-bit microcontroller. You have to print it into a buffer first. The buffer's name, I'm naming it as buff, but you don't have to name it as buff. It's just telling you it's a buffer. What is a buffer? It's storing some data temporarily in there, and you probably won't use it anymore in the future, but it's just a storage space. And I'm putting 20 spaces in this buffer variable, 20, but I'm not using all the 20 spaces. So it's just a space I'm creating to store something in there because I have to use printf first to get the correct format by using the specifier, which is %C. Okay? If I'm putting a C here, I'm actually printing out the character. So let's look at the alphabet 2. So what is a character at alphabet 2 location? What is that? What is the character at that location? X. Because this is 0, 1, this is 2. If I'm specifying this is alphabet 2, I'm actually trying to access X in there. And if I'm trying to print out this thing as a character, this is a specifier, and it's being printed to the buffer here first. It's taking out the first location in this variable first, which is buff 0. That doesn't matter, don't have to worry about that. And then I have to do a %C in order to print out or store that C in there. What's that?
So does the box string have 2 null spaces then? If alphabet is starting at 0?
No, it's a null at the end of this one, right?
But alphabet 2 counts box 0, 1, 2. So
0, 1,
does
2.
alphabet 4 have 5 spaces?
Yes. No, this is 4 spaces. No. So you define 4 spaces and so this is a 1, 2, 3, 4. That's just for the spaces. It's just a number 4. It's not counting from 0.
Okay.
It's just 4 spaces. So here you have 0, 1, 2, 3. That's 4 spaces.
So then why does alphabet 2 start counting at 0?
No, this is a location. It's directed to the address. Index, I can say.
Okay.
It's an index. I'm not counting. I'm sorry, I counted because I'm trying to let you know this is 2. It's not counting. It's just an index, because 2 is at the 2 location. That's the index.
Sounds good.
So here and here are different, right? Even though they look the same, but they are in the different places. This is trying to access this location. This is declaring this variable, even though they look the same. This is not trying to access anything. It's just declaring this thing has 4 spaces. This one is, oh, it already exists. I'm trying to access the index 2, whatever in there. The good question. Because people will get confused. They look the same, but they represent different things. So alphabet 2 will be a location in this variable, will be X. And if I'm printing out this one to a serial monitor, I need to use the printf first, this function first, to print out this one in the buffer using a character format. So it's going to be X being stored in there. And then I'm using the same thing, start the serial begin, serial print line, and then I print out buff because I don't have anything else in buff. Okay? So even though I have a lot of spaces, but they're all empty, so I can directly put a print line buff without any index in there, which is fine because buff has nothing else. And you can try that. You can put an index over here. I believe it's going to print out nulls or just zeros or nothing. Probably nothing. It's going to be nothing afterwards. But you can see that one I already have in the buff, and then I print the buff. So that's how you have to do it in Arduinos. In your computers, you don't have to do it, but here you have to do it. So the question here is, if I'm using %U to replace %C, what's going to happen?
Print the ASCII code as an inside.
Yeah, so what is the ASCII code? So look at the back of your in-class exercise. There's the ASCII code appended to it. You see that? Okay. So look at X. Where's X? Lowercase x, right? It's over here. You can see its decimal is 120. Hex is, what is hex? Hex. Who's that 78? 5 points off. What else?
7, 8.
Yes. It's not 78, it's 7A. It's OX78. Okay. So in that case, come back. %U. U is what? unsigned what? Unsigned decimal.
Yeah, so it'll still be
So it's gonna be what? Eventually you are gonna see what in your serial monitor?
120.
120. Okay? What about this?
Yeah.
7, 8. Okay, cool. You'll see there are other specifiers over here you can look at, and you can even make it fancier, right? Sometimes, for example, this one. You can add a number there. You will specify the length or width of your printed number. Okay, even though you don't have that many numbers in there, but if you define space, it won't take the space. So all the numbers, training numbers won't take the space after it. Start defining a certain width of that number after printing it out. You know what I mean? This one. So if you do so D is a signed decimal, right? Is it signed decimal? Yeah, signed decimal integer. Why is making a difference? Let's see. There's a 0B, that's a binary number. 1000, okay? This number to be printed out. If it's unsigned, if I'm using this, what I'm printing out? Yeah. I'm doing this, what I'm printing out. Yeah. Make sense? That's making a difference. It's treating this number as a negative number, as a two's complement, signed or as unsigned. Okay. What about this?
Unsigned X. Oh.
X is what? If I do person X, what's gonna happen? Yes. Cool. Any questions on this? Defining a space. Looking back, coming back to here, defining a space. Still the same number, okay? I'm doing 5D. 5D, which are expecting? 5 space, right? So if you print another number after it, it's gonna start from here. Otherwise, it's gonna directly start from here. You know what I mean? So that's the difference. So it's the width of the result it's gonna take. And the floating numbers is defining how many digits after the decimal point. There are even more. I just didn't list it. But a lot of times we don't use float numbers, floating digits in here in our programming. It's taking a lot of space in the memory. Try to avoid it as much as possible. Okay. Unless you have to. What's that?
I don't really understand what you mean by the 5 spaces real quick.
5 spaces is just the when you print it out, the result is taking 5 spaces. That's it. So in your printing, the result, right, you are seeing the monitor, your monitor, it's gonna define a certain width. Actually, if you don't have anything after it, right, so you won't be able to realize because it's just empty. However, if you are printing another thing right after it, you'll see the number will start from here. Like I'm printing another number, like 0x something, right? It's gonna start from here instead of here. Because this defines the width of it. You know what I mean? It's taking that space, it's occupying it. Right?
Okay.
Cool.
Thank you.
Good question. Any other questions? No? 7 minutes left. You guys are smart, you can do it.